Okay, in this question, we want to answer to the parts from A to G. All right. So the first question is to look for the multiple regression equation, and we do as usual. So we're gonna download the table, raw data, click on this window, and open in Excel. Right. So done with this. So open it. Make sure to enable editing. And obviously here they give you all the variables, right? So we have the Y, the total number of standby hour, and then the first column, the Y, the X1 and the X2. So you don't have to wonder which one is the variables, right? It's already written for you. Okay. We're gonna go to the data table, data tab, data analysis later on, and we're gonna have the menu. Now we're gonna select our data analysis type, which is regression. Select it, say OK. You're gonna have a dialog table. We're gonna start filling up. So the input Y range will be first column. Click on this arrow. Select all the values here. Go back. We're gonna input the X's. So we're gonna click on the arrow again. Select the X's, both of them, X1 and X2. Go back. Now, because we selected the labels, do the labels. That will output is going to be on the same worksheet. So I'm going to click on this. That selects the cell where you're going to be starting the output. And that's all. Say OK. Get your data analysis output. All right. So for the first question, we want only this information here from the table. We're gonna go and change the color. Here we go. Okay. Right, starting with the y-intercept first, and you can see it in the intercept here. We want to round to 1 decimal place, so I'm gonna select this number, Control copy, go back, Control V. Then I'm gonna round it to 1 decimal place, so it's gonna be 0.669. That will be 0.7. Then the second one, this, Control copy, we go back, paste it. That is positive, so we're gonna round it 1.76. So that will turn into 1. And the last one, B2, and we notice here that B2 is negative, so you're gonna be a decrease. Paste it, 0.014, so you're gonna be 0.0, and that's all. Check, we good. Question B, so the interpretation of the two slopes B1 and B2. So let me remind you again about this. Usually whenever you keep x2 fixed, so x2 fixed, that means the remote hours fixed, and you increase x1, that the total staff present, by 1 unit, you will increase the standard hours, which is the y, by the value of b1 units, and vice versa. If we keep the x1 fixed, that means the total staff present x1 is fixed, and increase the remote hours, which is x2, by 1 unit, you will increase the standard hours y by b2 units, and the best choice should be B in this case. And we notice here I said increase b2 unit, but b2 is negative. It means instead of increase, it will be decrease, right? So that's why we are using decrease in standard hours of y1 or by b2 units, right? Okay, so we check it. That's the right answer. Okay, here for question C, we are looking for the meaning of b0, which is the y-intercept. Okay, how can we get the y-intercept? By imposing x1 0 and x2 0, which means the total staff is 0, it means no staff, and the remote hours is 0, that means no work off-site. And in this case, you're gonna end up with a negative number of the y-intercept, which is minus 330, and that is no meaning for it, right? You cannot have the standard hours negative number of hours. It has to be minimum 0. So the best choice would be the A. All right, so here they are telling you no staff, that means x1 0, and no remote hours, that's x2 0. All right, and there is no particular meaning for this. Check it, we good. Okay, for question D, we want to predict the mean standby hours for a week in which the total number of staffs is 310 people and the number of remote hours is 400. All right, so I'm going to do this question on Excel, and I'm going to be using this formula over here, which is the y hat is going to be x0 transpose A times the value of the beta hat. All right, so let's define x0 first. So x0, you're going to start always is a vector. You're going to start with 1, and then you're going to put the value that they provided to you. So we have here x1 310 and x2 400. So I'm going to input 310 and then 400. And this will be your x0. Now for the beta hat that we are looking, that's going to be nothing other than the coefficients over here, the coefficient b. I'm going to copy it and paste it over here. So I'm going to label it as b, right? The b coefficient, b0, b1, and b2. Okay, so let's look for the y hat, and the y hat is going to be equals. Let me zoom in. So the y hat is equal sign. I'm going to multiply matrices, so it can be m multiplication, tab. I selected it, and then I'm going to use the transpose right now. So T transpose and use a tab, you get it, and then you select this vector matrix, close the parentheses there. Now I'm doing a multiplication, so I have to input a second matrix, and the second matrix is going to be this coefficient over here, right? And close the matrix, enter, and that's going to be the value 160.56. Let's plug it in, and you want 2 decimal places, so 160.56. Good. Now for the following question, we want to construct the 95 percentile confidence interval. So again, we're going to do it on Excel, and this is a lot of work, so hang it there. So for this question, we're going to use the following formula, and some of the variables already found it. So here, for instance, the mu y x0, and that's nothing other than the y hat that we just found. All right, y hat 0. Another component that we got already, the x0 is already there. So if we know the x0, we know x0 prime, which is the transpose. And what I'm going to do is I'm going to start calculating this entity here first. And just to remind you that I can rewrite whatever under the radical sign as sigma hat times square root of x0 prime times x prime times x inverse times x0, right? So I'm going to proceed first of all by calculating x prime times x, and then proceed from there to get the -1. All right. Now, what I want to do first is to define the vector x. And your vector x is nothing else than x1 and x2. So I'm going to go all the way up and select the first number in x1, select x2, and go all the way down. So control copy, and then I'm going to paste it right here. I skipped the first column because the first column always has to start with 1. So I put 1 and then 1, select them both, and double click in the corner. This you can extend it all the way down. Okay, so this is my matrix X. Now I want to calculate what is going to be X prime, that's the transpose, times the matrix X. And in order to do this, I'm going to click here, and I'm going to use the multiplication of matrices. So that's again start with mm multiply, that's the only function. Click on tab, then you're going to use the transpose, that's the prime, and then tab again, then select the matrix X. Alright, once selected, you close the parentheses, that's the first matrix, and then comma, and always for multiply is always 2 matrices. Alright, so I'm going to select the second matrix, and that will be the matrix X itself. So I'm going to select it again, all set. Then close the parentheses and enter. So that's going to be m multiply the transpose for matrix X, comma, select the matrix X, enter, and I get matrix 3 by 3. So now what I'm going to be doing, I'm going to be calculating the x prime times the x and inverse. In other words, I'm about to calculate the inverse matrix of this. So I can copy it, put it here, and what I'm going to do, I'm going to do the inverse, right? So okay, and this in Excel is going to be equal sign, and then m for matrix, and then inverse. So INV, and you can see it inverse right away. Tab, then what you're going to do, you select the matrix here, close the parentheses, and enter. And this is the inverse matrix. So that's a x prime times x in -1 exponents -1. Okay, so right now, again, I'm gonna calculate this entity under the square root. So I'm gonna calculate x0 prime times x prime times x inverse times x0. And we can notice here there are multiplication in this place, and there is a multiplication here, and there are 3 matrices. So let's do it. I'm going to do it in 2 steps. So first of all, let me type it in. So I'm going to do this in 2 steps. First of all, I'm going to multiply the transpose of x0 times the inverse matrix. So that's going to be equal sign m multiply, and then the transpose, selected, the tab. I'm going to go to the x0, which is this matrix over here, select it, close the parentheses, and then comma, and multiplied by the inverse, which is all this matrix over here. So close the parentheses, and this is the first multiplication. You're gonna give me a row matrix, and then I go back to the same cell, double click, and then I'm gonna start in the beginning. I'm gonna do I'm multiplying again, tab, you're gonna open the parentheses automatically, and then you're gonna go all the way toward the end, and you're gonna put comma, and now you're gonna select the second matrix, and the second matrix is gonna be just x0. So I'm gonna go to x0 and select it. Okay, now close the parentheses, and that's all. This should give you only one number, and that number is 0.068. So this number is represented by this part here. And as I told you earlier, this is, I'm going to write it down as y0 hat minus the t alpha over 2. I'm going to calculate it later. And here, because the sigma hat squared and squared, you're going to cancel each other. So this is sigma hat times the square root of this entity, the green part, which is x0 prime times x prime x minus 1 times x0. That's the square root. Okay, so let's start looking for the other variables. So the first part, we're gonna do the standard of error. So the standard error is given by Excel, and this is basically the sigma hat. Let me highlight it. So this is the variable I'm looking for, and that one is given by Excel, and this is the value right here. So what I'm going to do is 35.31. So I'm going to put here equal sign, and then go and select that value 35.31 and enter. So I get that value. The second value I'm looking for is the t value. So the t here, t alpha divided by 2, right? And for this one, I'm going to use the t dot inverse, and I'm going to select the second one with 2 tails. And then he's asking me about the probability, or the probability is the alpha value. And the alpha value here is going to be 0.05. I'll explain it in a moment. And comma, and degree of freedom, it should be from the table again. So the degree of freedom is given to you, and is a residual degree of freedom here. So this is 23. And close the parentheses. That's it. So this is going to be t dot inverse dot 2t. This is 0.05, that's the alpha, and that's going to be degree of freedom. And that's going to be your t value. So now, why did I choose alpha equals to 0.05? And the reason is really simple. We always have the alpha value equals to 1 minus the confidence interval value. So in this case, what we have here, the alpha would be equals to 1 minus 0.95, because you are looking for the 95 percentile, and that's going to be 0.05. So this is your alpha value. Okay, so we're done with these values. We might want to determine as well the half interval, and the half interval in the formula is represented by this box. All right, so it's basically the same expression as here, and you can see one time we're gonna count it negative, and another time we're gonna count it positive. So it's gonna be plus or minus, right? All right, so let's get into it. So the half interval is gonna be equals, according to your formula, it's gonna be the t value times shift 8. We multiply by standard error times shift 8 and the square root right now, sqrt, open a parenthesis, and square root of the whole entity, which is we just found earlier. This is the value, right? And close the parenthesis and enter. So just to remind you, this value we just entered under the square root here is nothing else than the same value here, right? Okay. And that's going to be 19.099, right? Now, so here finally we can calculate the upper and the lower. The lower is going to be equals the y hat, so that's y0, and we're going to click on this value, and then we're going to take away minus the half interval, which is this value, enter. And for the upper end we're going to do almost the same thing, equal sign, we're going to click on the y hat and we add the half interval, which is this one, and enter. So those are the two values that we are looking for. Let's plug them in and double check. So here, copy, and we want to round to 2 decimal places, so 0.46 should be fine. So the second value, we copy it and then we paste it again, and 2 decimal places, it's going to be 0.66. Check it. Okay, that's worked. Nice. All right, so question F, we want to the 95 percentile predictive interval or prediction interval. Okay, so for the prediction interval, we can notice here this is the formula, and the only difference is almost the same variable. The only difference we have is this one under the radical sign, which is extra. That's all. So all the work is already done. We're gonna copy, paste, and change this formula, and we're gonna add an extra one there, right? Okay, so first of all, we're gonna copy all this work. We're gonna paste it, and we paste it as values. Okay, and the half interval is gonna change, and these two are gonna change as well, right? The rest is gonna be the same. And okay, so instead of confidence interval is prediction interval, PI, and this formula for the half interval, so let me color code it. Okay, so the half interval, this is going to be equals, I'm going to start it from scratch, so you're going to be this value, the T alpha over 2 times the standard of error times right now the square root, sqrt, open a parenthesis. So we're gonna put that one there plus the value over here. So I'm gonna select the next cell, enter, that the value, right, we found earlier, and I'm missing a parenthesis. It should be fine. So this is on the way actually. Okay, so that's a half interval. Now we're gonna do the same thing, equal sign, we're gonna go to the y hat. All right, so we're gonna do exactly the same thing. We're gonna go to the y hat and we take away the half interval, enter, and then we do the same thing. We go equal sign, we select the y hat, and then we add the half interval and enter. And those are the two values. Let's plug them in. Let's check it. True. So for this question, obviously we used both variable to predict the standby hours, and we used the staff present and the remote hours. So that will be B. We are using both of them, and that should be the right answer. It is. That's all.